Start garta huncha?
Yep,
Okay.
we are live now.
Hello, everybody. Good morning to you all from Kathmandu. My name is Shreyasha Paudel. I am the Research Associate at the Global Institute for Interdisciplinary Studies, and I'll be moderating the webinar for today. We're live on Facebook as well. Thank you, everybody, for joining the webinar. I just want to go first ahead and introduce our organization. The Global Institute for Interdisciplinary Studies is a Kathmandu-based interdisciplinary research-based organization. And we're working with multiple stakeholders in various holistic fields to conduct interdisciplinary research to generate credible knowledge for transformative change in Nepal's development policies. You can log into our website, theGIIS.org, to know more about us. We're located in Patan, and today is our 4th episode of our webinar series called AI and Emerging Technologies for Sustainable Future. This research initiative at GIIS was basically introduced to conduct research, development, education, and public discourse on emerging technologies to generate knowledge, innovate, support, and catalyze sustainable development. And we are running this webinar series for the past couple of weeks with our diverse guest speakers who talk about diverse aspects of emerging technologies, along with the introductions to state-of-art technologies. And they also bring holistic discussions on the applications and impact of these technologies and how we can understand, access, and create technologies for our collective sustainable future. And today is our 4th episode. And most of our previous speakers have presented on different topics such as AI and sustainability discourse, use of AI in agriculture, and recently on health as well. And today we have our guest speaker, Ms. Shreyasha Paudel. Please allow me to introduce her. She is a technical project lead at the Ford Motor Company and currently develops models to quantify uncertainty and bias in computer vision algorithms. She has expertise in computer vision, Bayesian machine learning, sensor fusion, and automated vehicles. She's interested in the societal and human impact of AI technologies and is interested in understanding how the context plays a role in algorithmic bias. And that is what she will be talking about in this webinar for today. Before I hand over the floor to her, I would just like to give you a quick update that we'll have about maybe 30 to 40 minutes of her presentation, and then we will do a quick question and answer session, and then we'll wrap today's seminar. We're live on Facebook, so anybody joining from Facebook can post their questions on Facebook, and participants on the Zoom can post their questions on the chat box. And we can go ahead with the question and answer round at the end of our session. With this, please allow me to join and invite Shreyasha Ji for the talk. Shreyasha Ji, the floor is all yours.
Thank you. From one Shreyasha to another. Thank you everybody for joining. You guys can see my screen, right? So my name is Shreyasha, and the other Shreyasha gave a really lovely introduction. So without further ado, I'm gonna go into my presentation. In my work, I work on automated vehicles, and I look at biases and data sets for automated vehicles. But my presentation today is not just about automated vehicles. I'm talking about machine learning, and more than that, of any automated algorithms that can be. Some of this is practical to machine learning and AI applications. Some of this might be even generalized to any algorithm that exists out there. With that, since you've come to my talk, let's start with a little bit of icebreaker. When you hear bias in machine learning, what does it mean to you? You can go to this website and enter your words. It can be a word, it can be a sentence, and I'm hoping with a little bit of engagement, we can see thoughts from everybody. We can get a pulse of the audience, and we can talk about it some more. Okay, as you enter words, it will show up. Please don't make me sad.
Shreyasha Ji, can you also post the link of that link on the chat box? Just
yes, I can.
For our participants. Thank you.
You should be able to access it both on your phone and your computers. Yes, no. There you go. Let's give 1 more minute and then we can move. Perfect. Yes. Gender bias, sampling bias, error, human bias. Those are all the things we all talk about. And keep entering. We can check this at the end as well and see if the words we see change a little after I talk about this. So with that, and that was a great setup, I am going to move to some, and let's present. Yeah, I'm going to move to some myths about bias in machine learning. I saw a lot of data set bias, human bias there. So one of the first myths we hear a lot, and this is not just people who don't know about algorithms, right? Many experts also talk about this as like bias in machine learning is a data set problem. It is a data set problem, but there's also more to it. And I hope by the end of this talk, you'll hear about it. You'll learn some more about it. The second myth that we hear often is that algorithms do not create bias, they transmit biases. Again, this is not entirely false, but algorithms can also create biases, as we will see. And then the last thing that we keep hearing about is biases can be fixed to make the algorithm more objective. I do not know what objective means or what unbiased means. Any algorithm, in my opinion, is biased. The trick is to make it biased towards the goals we want versus the goals we do not want. And so there's no such thing as an unbiased algorithm. We just want it to be biased in a way that is desirable or in a way that is fair. Some of the words I saw there said unfairness. And yes, unfairness is a bigger problem than bias. Moving on, let's talk about some of the types of algorithmic bias. Or in other words, it's not just a data problem. I really like this diagram from a paper that came back a couple of years ago. I put the link of the paper in the slide as well. They have really this nice diagram showing where biases might enter an algorithm in different aspects of it. The top picture, part A, is data generation, and this is what we usually call data set bias, right? The biases that exist in the data sets in the world that then get captured and we call data set bias. But as the bottom part says, that's not the only source of bias. The bias can come from model itself, as it's called aggregation bias. It can come from how we evaluate it. What are the metrics we use? The metrics we choose will favor one outcome over another, and that is a bias. And then lastly, how we deploy the model into the world, right? What purpose it is used for, whether it is designed for it or not, is another source of bias. So every time we do something with an algorithm, we do insert bias into it. And understanding this is crucial to know which biases we want and which biases we do not. So let's go over each of these biases one by one. I will give some examples. If you have any questions, please ask them so that we can have slightly more interaction. Full disclaimer, I live in America right now, so a lot of these examples will be US based, which is another bias that we have. And hopefully in a few years, we'll have examples of biases from not just from the United States, but rest of the world as well, since the rest of the world has even more sources of biases. So to start, there are two examples of machine learning based predictive algorithms that recently got canceled. One of them is University of Texas was using an algorithm to evaluate PhD applicants. And then later they discovered that they were using past students as their ideal student. And in the past, they only had men and mostly white men. So their algorithm was rejecting non-white men applicants without even looking anything about the application. And this is a case of historical bias, since historically white men were more PhD students. Same thing about Amazon. It was also its recruiting tool, since Amazon employees are mostly men. It was recruiting more men and rejecting women, even though they had identical resumes. And so this bias comes when the data is perfectly measured and sampled, but the world we live in, where the data was collected from, has outcomes that are not wanted, right? This is a bias against non-white men, mostly because the world right now is biased towards white men. The next bias, which is similar but slightly different, is representation bias. And this is when we sample things not perfectly. So the world is already biased towards some outcomes, but then when we sample it, we again sample some outcomes more than other. For example, we heard a lot about mobility data being used to do contact tracing, prevent, like do lockdown, control lockdown to prevent COVID, etc. But then mobility data comes from smartphones, and older people, or in America, non-white people are less likely to use smartphones. So mobility data only captures people who use smartphones, not the entire population. Similarly, ImageNet, the most used data set for computer vision applications, has multiple distressing biases, one of them being geographical bias. So most of the data from over here comes from North America and Europe. This is another mostly used image data set, open images data set. Here, most of the data comes from America. So this data set is biased towards where the data is collected. And this is representation bias, right? Most of the world in this map is not really represented in the data set. Or to put it mathematically, when certain parts of the input space or input set is represented and others are not, this is representation bias. Moving on to measurement bias. I don't know if you can see, it's so small, but I'm trying to show the initial diagram one by one. So measurement bias is when we measure the wrong thing. I really like this comic because it represents it really well. They wanted to model to detect drug smugglers, but they used a sniffer dog as a test. And this is a proxy. So what happened was they just used like wrong signal to measure the thing they were trying to, and the model learned the wrong signal. That also happens in the real world. Again, going back to Amazon's recruiting tool, what they were measuring was an ideal employee, but there's no mathematical way to define an ideal employee, right? What is a good employee? So what you use then is you use your past employee as a proxy, which is a measurement bias. You are trying to measure an ideal employee, but then you use past employee. Or in the second case, there's a predicting algorithm where they're now predicting future criminals by measuring past criminals. Again, it's a proxy, and since our world is historically biased, it produces biased results. There's a historical bias in there, but there's also measurement bias because we're measuring the wrong thing. An example is, again, right, is the definition says, we usually can't measure complicated things that happen in the world, and we try to build abstractions. So we try to predict criminals by looking at past criminals. We try to predict like excitement by looking at facial expressions. We try to predict like feelings by looking at words, and all of them as just proxies. So we sometimes measure the right thing, but sometimes we do not. And so that's where the measurement bias comes in. Every time we choose to measure something, to detect something, we need to be very careful whether what we're measuring is actually correlated to what we're detecting or not, because sometimes it may not be, sometimes it may be, but not in the way we want. The second one, then we move to the other part of the bottom part of that initial picture, evaluation bias. Say we figured out our data set perfectly, right? We removed the undesired outcomes. We represented the desired outcomes really well. We have a perfect thing we're measuring. Even then, we can have evaluation bias, and this is an example. Here, this is an example. This is a landmark paper that came out in 2016 about facial recognition and how all these big, well-known companies, right? Microsoft, IBM, whose algorithm was being used by thousands of people, were doing much better for like lighter subjects. So the fairer you were, the algorithms were doing better, and then they were also doing better for men versus women. I saw one of the words that was posted earlier was like biased against men. And so what was happening in reality, how did we come to this was, it wasn't the algorithm's fault. It it was more a fault of like where we are evaluating. The benchmark data sets that we were evaluating on mostly had white men. So over time, as we optimized for better and better performance, the algorithm started to do better for the data set that it was being evaluated on, and then did not consider other data sets. That also happens in the driving world. Recently, there came a paper where we were not detecting darker skinned pedestrians, same reason. Most data sets we have has lighter skinned pedestrians, and most data sets, since they are usually from America or Western world, don't even have a lot of pedestrians. So the algorithms does not do very well because it's never been evaluated against data set that's not part of it, right? Again, it's because what we are evaluating on, our benchmark data, does not represent where this algorithm would be used. That's a kind of bias. It can also go the other way, where you want an algorithm to really work for pedestrians, right? Think about cars. It's okay if we hit a trash can, if we hit a pool, but you really don't want to hit people. Then one of the things you can do is build an evaluation data set which has lots and lots and lots of people and maybe not have enough of other objects, because that's not as much of a priority. Lastly, and in the interest of time, I am not going to go over aggregation bias a lot. This is the definition, again, from the same paper. And if you have questions, please do ask them. But aggregation bias comes when one model is used for groups with many different characteristics. And an example would be misinformation models used by Facebook, Twitter. Again, they're usually designed for the Western world, North America, Europe, and then they're deployed all over the world. And what happens is a lot of misinformation in Nepal, in India, in Myanmar goes undetected with very, very sad consequences. Another example, less sad or more sad, is stroke symptoms are actually very different for men and women, but most algorithms are sometimes made like for the entire population and usually with only male symptoms. So it doesn't work for women because the symptoms are very different, but we just assume it works for everybody. And this can also be not an algorithm thing. Like, for example, car seats are also usually only tested on men and assumed to work for everybody. But because women are physically different, it actually turns out that seatbelts sometimes can be more dangerous for women in the case of accidents. Last one is deployment bias. So this is what happens at the end, right? Say you model everything correctly. You did exactly what you wanted to do. You got a perfect algorithm. If you don't explain to people what that algorithm is when you put it out in the world, or if you don't have safeguards against undesired use, you can get some very weird consequences. An example is this chatbot Tete, released by Microsoft a few years ago, where they wanted somebody to just be like interact with humans and learn to speak like people, but people started gaming it and teaching it to say more and more racist and bad things. So by the end, she was like, Hitler was right. And one of the reasons this happened was when it was developed, nobody considered that people on the internet can be rude and racist and can teach a chatbot to do it, right? It wasn't designed incorrectly. It was deployed in a place where it wasn't designed to work in. And that can also happen in other things. Healthcare might be one, or like detection facial recognition might be another, where a facial recognition designed for lowercase like Snapchat filters, if you then use it to detect faces in like high stress scenarios, or like, then you will get very different results. And that's not the fault of the algorithm, that's the fault of deploying it where it shouldn't be. And this is deployment bias. Yeah, so it's when there's a mismatch between the problem a model is trying to solve and the way in which it is usually used. So with this, any questions, moderators? If not, let's move. Okay, if not, let's move to the next is, we talked about all these biases, but why does it matter? Aren't humans also biased? Don't we talk about teachers who have a fight with their wives and deduct all our scores in SLC? Wouldn't algorithms be better than that? Can't we design them to still be more objective? The answer is yes, and maybe. Machine learning can amplify bias. One of the reasons we really need to be careful about this is because these algorithms can not only encode bias, they can amplify them. For example, in this example, right, we're translating from English to Hungarian and then Hungarian to English. Hungarian has no notion of gender in its language. Male and female use the same pronouns, same sentence structure, but by translating, we're encoding the bias from English language to Hungarian. And if this whole process was automated, nobody would even detect it. So think about so many things that might get biased from one place to another because machine learning algorithms are usually deployed, not just in one place, right? They're deployed globally. These big companies that everybody uses, that they might be, if they are not careful, encoding a bias from one place and then amplifying it to the rest of the world. And with that, as they say, with great power comes great responsibility. The other problem is algorithms are trusted more than humans. We all are biased, so we know humans are biased, but there's this notion of objectivity to algorithms that we think algorithms know better. They will mitigate our biases. So a lot of the times we give their biases a free pass, especially if it's a bias around like something that cannot even be measured, right? Say ratings for drivers or ratings for teachers, where how do you define a good teacher? You cannot, so you can't even judge whether the algorithms are good or bad and then use it. Sometimes we may trust the algorithms more than humans. The second example here is really funny because it's something that could be verified, but some tourists almost drove into the ocean following a GPS. I have definitely driven into wrong intersections. One way sometimes following the GPS because it was a new area and I trusted the map knew what it was doing. I've definitely driven into areas with a lot more traffic, trying to avoid traffic because the map said so. So again, by trusting algorithms, because we trust algorithms, we do need to provide more scrutiny to them to make them unbiased or to make them more fair compared to like humans. Humans are also grow and learn while algorithms encode in time. And the last thing, I already said this before as well, there is no objective algorithm. As Kathy O'Neill nicely says in her book, algorithms are opinions embedded in code. And what this means is it's not an exact opinion, but who chose to define the problem, right? How do you define what you're measuring, what you are predicting, how you are predicting is an opinion, and it will change from person to person. It will change from team to team, and that will have consequences. Same way with data set you use, which metric you use, how many times you test, all of them have real world consequences. And that way algorithms are opinions. And in one way or other, right? Whether you choose once or twice or thrice, there is no right answer. It's just what you are trying to do, and whether what you do is results in what you're trying to do is where the disconnect lies. So one of the things I hope you will really get out of this talk is to get away from this idea of like an unbiased algorithm. What we want is a fair algorithm. What we can have is an algorithm that will not do harm, but we will have biased algorithm. The algorithm will just be biased against harm, however we define harm. So what next? If algorithms are biased, they might be more biased than humans. They might make biases worse than humans. Should we just give up? Is machine learning and algorithms never to be used? Definitely not. I have a degree in AI. I really enjoy working in AI. I think there's a lot of promise, but I think there's also a lot of risks. And what we need to do is be careful. At the end, I have a couple of things we should think about before using machine learning algorithms, before deploying machine learning algorithms, before talking about them. And these questions came from this interesting talks. A lot of structure of my talk also came from this talk. So please definitely watch it if you're interested. But going back to the questions, the first questions you should always ask is, should this algorithm be built? Just because you can do it, just because you want to do it does not mean it needs to be done. And sometimes we hear the excuses that if I don't do it, somebody will do it and they will do it worse. But that's just a lazy excuse. If everybody said like this should not be built, I will not do it, it wouldn't be built. And so at the very least, ask whether this algorithm needs to be built. Then the second thing you ask is, if it is to be built, what biases might lie in the data? The model, the metric, all of them. I'm just using data as like a shortcut. And once you ask that question, you ask that question to the rest of the team and check if the team has different experiences as you, right? People around you, everybody comes with a different set of experiences. So they bring a different kind of bias. And the goal is to have all the types of biases accounted for, whether it's desirable or undesirable. The other thing you do is check if the code and data can be audited, because nobody's perfect. No team is perfect. You won't be able to capture everything, but what you want is to be able to check intermittently whether there's biases, whether it's doing what you want for both code and data. The other thing you want to do, and I think that what are the error rates, right? Again, when you check for error rates, don't check for just the overall error, check for difference of categories. Be it is a simple problem or be it complicated problem, there are many use cases, and definitely check error rates for different use cases, because when things fail, they don't fail in the same way in all the places and all the cases. The second question, the last question is the machine learning, and this is specific to machine learning, is it better than random sampling, rule-based approaches? Because I have seen algorithms, especially something stupid, right? Like detecting a gender for names, which in overall does as well as a random guess. Or sometimes you make this like complicated black box machine learning algorithms, and then it does worse than a simple rule-based approach, because some problems can actually be defined with rules. And so it's always a better question to ask is, do I need this complicated approach? Do I need a simpler approach? Can I just guess and get as good a result? Again, we tend to trust algorithms. So sometimes we think like machine learning is doing amazing when it's doing no better than a guess. And then the last thing is, if mistakes are detected, how do you handle it? Can it be handled? If this is working in real world with real people, can they come back and tell me my algorithm is wrong? If it is wrong, can the outcome be changed? Because again, in things like policing, maybe banking, maybe even education, this is important, right? A few bad cases can sometimes destroy somebody's life. So always be careful of like whether mistakes can be detected and handled and appealed. So yeah, that is all I have. Short and sweet. But the main takeaway is not that algorithms are bad, do not use them, biases are bad, but more that biases exist. We know different places biases can come from. Some biases are good, some biases are bad. And we want our algorithms to do the things in the way we want, right? However we define. And so be careful, think about it, ask questions from like people with different life experiences than you, and develop algorithms in a way that it's more fair. It causes less harm. With that, any questions? That is all I have. I also have a bunch of resources. Some of them I've used in the slide. Some of them I have read and enjoyed. Most of them are designed for general public. But if somebody wants like engineering specific resources, I can share that as well.
Thank you, Shreyasha Ji. I think that was a really comprehensive presentation, especially because you gave so many examples about different types of biases. And most importantly, I think the takeaway was kind of your perspective about like, I think that unfairness is worse than bias, especially in this developing data sets and benchmarks. So I think that was something that was a takeaway for me as well. Yeah, I think we might have a few questions. I think we can probably begin the question answer session now. Sanjay, do we have any questions on Facebook?
No, we don't have it.
Can I ask one question?
I think Dovanji has a question. Lakshmi.
Hello. Can I ask one question? Okay. Thank you, Shreyasha Ji, for very comprehensive. It's another session said, and it's also very interesting. And you have talked about different types of algorithmic biases. As far as I know, the bias towards the inventor, like whoever write the code, whoever invent something, that is not the new thing. For example, the writing pen, the size of the pen is designed for the man hands because the inventor of the pen is male. Okay. The size of the commode is also designed for the male body, not for the female body. So, but these days, nobody questions, whether the size of the pen is right or wrong, or the size of the commode or shape of the commode is, built. Let's build the size of the commode for female body or something like that. Nobody talks about that because it's normal now. So do you think, one day this type of algorithmic bias will be normal, like the size of the pen or the shape of the commode? What do you think? It's just I just want to it's not like I'm pro towards these biases, but just want to throw these questions.
That's a great question. As a woman, I would definitely say no. But to flip your question, right? Pens, that's a great example. And when they were designed and when they were first built, they were definitely geared more towards men. Now I think we see a variety of different sizes of pens. There are even pink pens for women, which are then $10 more expensive here. But what is happening is like over time is like you identify customer bases, you gear towards different taste and sizes, right? At least for physical products. The problem with algorithms and problem that we recently see with ML, machine learning, and AI that you hear a lot is that it's scalable, right? Everybody wants to be the next Google. Everybody wants to deploy it to like millions of people. And it also doesn't help that you can develop it remotely from anywhere in the world. So there's also this disconnect between where the algorithm is being designed, who is then providing the data. A lot of data annotation does happen in our part of the world. A lot of data collection happens in like the West in developing countries. And then a lot of deployment happens all over the world. So there's this, because it's remote and it's like on the computer, I feel like there's a disconnect, which also makes it worse to detect these biases. My hope is that the more we talk about it, and that's why I like to talk about it, people become more aware. So the next time you see a pen, you are like, oh, this fits my hand. Does it also fit like some woman in your life whose hand it doesn't, right? So that's the hope. But that's an interesting way to think about things, and maybe some of the things will change. For example, for like voice recognition system, I know like I pronounce things a certain way so that my Google Voice or Siri will understand even though I have an accent. And over time, perhaps my accent will change to something the machine can understand, right? So that will happen. There's a feedback loop. The question is, do we want this world? And for me, definitely I do not. And so we need to stop before that happens.
We do have some questions on the chat box. First question is from Duvanji. She asks, people assume machines and algorithms are objective. This misconception can be a real problem, particularly in countries like Nepal, where data literacy is very low. What can technologists do to bridge the gap?
That is a great question. And that is a question I want to punt back to the audience, right? I think the best thing we can do is talk about it, give examples, show examples. There are also cases where the algorithms is more objective though. And so show both ways and show the path where we get there. For Nepal, especially, in my experience, and some people might be offended by this, is that technologists themselves believe algorithm is objective, which I think is a greater problem. It doesn't also help that our education is not very interdisciplinary coming from GIIS. So I think the first part is to make sure that the technologists understand what the limitations of things they're designing is, see the value in fields outside of technology in understanding these problems. And then we talk about it enough that the broader public also hears some parts of it.
Thank you. We have another question from Lakshmi Tiwari ji. She asks, how can we find bias in image algorithm?
So Lakshmi, the first thing is there will always be a bias in image algorithm. The trick is to determine what the bias is. And so if we go to this initial plot that I showed, you go and check with each of these points, right? You start with a data set, check what kind of biases there is. Is there historical bias? Are you measuring something that historically is, simple example, men versus women, right? More men than women. Say doctors historically is more men than women. Now it's almost equal. So is your data set capturing more doctors from the past, even though it's almost equal now? Then the next question you ask is this what you want? Because for some things, maybe you want more men. Who knows? Say you're collecting a data set for prostate cancer detection. You want all men. You don't want women in there. So that then you ask question is like, is this the bias I want? Always, is there a bias? And then is this a bias I want? Same thing with representation bias. When you sample population, did you cover all your bases? And that this cannot be done by one person. This has to include more than one person because nobody can think of everything. Same with measurement bias, same with evaluation bias, same with deployment bias. You include as many people as you can, you ask as many questions as you can. I don't have a formula, sadly. And then for some of the biases, you can use statistical methods to detect it. But the biases we talk about algorithms is not the same as statistical biases. So there's more biases than you can model with statistics. A lot of it also comes from just understanding our world and who interacts with it, and etc.
We have another question from Shreyasha. Shreyasha, do you want to ask the question yourself? Would you like to unmute and ask your question just to make it more interactive? I don't think she's here, but Shreyasha? Okay.
Hello.
Yeah,
Yes,
we
we
can
can
hear
hear
you,
you.
Shreyasha.
Hello.
We can hear you.
Can you hear me?
Yeah.
Yeah, of course. Thank you, Shreyasha Ji, for your wonderful talk, for your wonderful sharing of knowledge. It was a very wonderful moment. So my question is like, how do we avoid like data bias in machine learning? Like, is there any kind of specific method to avoid those kind of biasing in machine learning?
The best way to be as comprehensive as you want. Sometimes we hear more
Hello?
data.
Yeah.
Can you hear me? Can you hear me? Yeah. So the answer is to be as
Yeah, of course.
comprehensive.
Yeah.
Yeah, the answer is to be as comprehensive as you want. For some problems, more data might solve it, right? If your model is really big, has a lot of parameters, then giving it more and more diverse data will help you avoid a lot of the bias and learn the patterns. In some cases, that might cause the opposite. For example, if your model is small and not really generalizable, or if your model is really big and finding some shortcuts to fit into, more data might actually make it more biased. So the answer will be, it depends. It depends on your problem. It depends on your architecture. It depends on what you're trying to do. And as I said in my talk as well, sometimes the bias is a good thing. Sometimes you want your algorithm to be biased. For example, in self-driving cars, where I develop my algorithms, sometimes I want my model to be biased, right? I want it to be biased against hitting people. I want to be biased against stopping before it is safe rather than like moving. And then that causes like, so depending on your use case, you want to bias it towards more false positives and less false negatives versus more false negatives and less false positives. And with that, you also sometimes play with your data. And this is what I was calling representation bias, right? You sample examples of places where you really want your algorithm to work more than examples of paper where it's so examples where it's okay if you fail. So the first thing, and I will keep repeating this until for every single question, is you cannot remove bias. There will always be bias, and what we call objective, right? What we call completely unbiased is just bias towards status quo. What is today is what might be the thing. But as humans, we grow and change, the world grows and changes, the culture grows and changes. So bias towards status quo will just like make what exists today fixed in time, and that's also not something we want. So in general, what we want is to have algorithms work in a way that's like thought about and designed by humans and intentionally have certain biases. So what I would recommend is think about where you want your algorithm to work, what kind of cases you want it to really succeed in. And there's no such thing as a perfect algorithm either. Maybe if there's a paradigm shift, there will be, but right now it will fail. And what we want is for it to fail gracefully, right? Think about bridges, think about building roads. We don't assume that the roads will last forever. We design it such that when it fails in certain road conditions in certain number of years, and we can design it and use it in a way that by the time it fails, we've already made it better, or we've constructed a new road. Same thing with algorithm. It will fail, but what we want is we want it to fail in a way that is graceful, in a way we can expect and anticipate and prevent unintended consequences when the algorithm fails. And so we want it biased towards those cases. Hope this answers your question.
Thank you. Sanjeev Ji, we have another question from Sanjeev Ji. Sanjeev Ji, why don't you go ahead and please share your question with us?
Sure. Thank you, Shreyasha Ji, for the unbiased presentation on machine learning and bias. My question is that usually what we see in movies is that AI, machine learning are used to tackle terrorism, to tackle any sort of cross-boundary issues that you might have. So I was interested to know how we can use machine learning for public diplomacy. Like if there is any science that we can use for the betterment of neighboring countries like Nepal, India, China, how we can use AI for the public diplomacy without being a bias. Thanks.
That is not my expertise. I do not know how to answer this question, but I would ask you to think about what public diplomacy means, right? There's never one correct answer. So automating it, to me at least, seems like a bad idea. Also, there's trade-offs, right? It's usually compromise, and with compromise, you want a lot of flexibility. So what algorithms are really good at is doing things that is consistent, that is measurable, that is fixed, that can be like, that is repeatable. None of them seem like, and this is not my expertise, so take it with a grain of salt, but seem like a part of public diplomacy. So I would be very careful using where it is. But that said, language translation, there you go. That's an application. You can probably use language translation to like navigate different languages, different cultures. Just be careful that biases from one language then does not port into another.
Thank you.
Considering our time, we have 3 more questions, so we might discuss 3 more. There's another question from BJG. BJG, would you unmute yourself and share your question with us?
Hi, yeah, sure. Shreyas, first of all, thank you for the presentation. So my question was, seems like a big chunk of tackling bias is about being aware of the sources of bias when building out our systems, and perhaps even going through the questions that you posted there, or checklists for what to do and what to be aware of. So these are things as a practitioner we should be aware of, but I was wondering what areas of research there are around tackling bias. I know maybe developing algorithms that are more immune to bias, or just thinking out loud? So yeah, more what are areas of research as opposed to something practitioners need to be aware of?
Yes, so on the technical side, a lot of people are looking at ways to statistically model biases and the conditional distributions that I was talking about, right? Bring them out mathematically so you know how your data set behaves, what the input output feature mapping is. The other big area of research is explainability. So even though there are these outcomes, trying to backtrack and explain how we got to this outcome is another research, which will then shine a light on these biases. The third one is defining mathematical notions of fairness. Again, right, what does fairness mean? How do we encode what we say fair is like mathematically so we can put it into algorithms? But besides technical mathematical engineering research, there's also a lot of research, interdisciplinary research, right? The philosophers are thinking about what does ethics mean, what does bias mean, what does fairness mean. The anthropologists and sociologists are looking at impact of algorithms in the real world. How do people interact with these algorithms? How do developers think about work in the workplace, think about doing these algorithms, designing these algorithms? How do annotators from different parts of the world, mostly uneducated annotators, are encoding bias into these algorithms? So there's a lot of mathematical things we can do, but there's also a lot of questions that cannot be answered just by mathematics. You need to look at our society, look at the messy, complicated humans and how different human beings react over time to understand these biases. So those are all the research areas, very interdisciplinary.
Thank you.
Thank you. Shreyasha ji, do you think we have still a little bit of time to take 2 more questions?
I think so. We have
Okay.
5 more minutes.
We have a question from Bibik ji, but before that, I just wanted to share, Santosh ji has just shared something that, Santosh ji, would you like to share something that you've posted on our chat box?
Thank you, Shreyasha ji, for the presentation. I guess like understanding the root meaning of the biasness, it always comes from our prior knowledge and experience, because we already have something in our mind and we see something and we're being judgmental or being something like that, right? And a system that like generates results based on like previous data. So how couldn't that system be biased? I guess there is no escaping from it. But the I think the point is like reaching to the point, trying to reach to the point like where the every system is might be unbiased, but I think there is no escaping from it. So it's not a question. It just maybe a point.
Yes, I think you put it really nicely. That's what I'm trying to say. I would just add a little bit. Is the point is not to try and be away from the bias, but try and move toward the biases that are more desirable, right? For example, in Nepal, we can all agree caste system is bad, or we can all agree sexism is bad. Hopefully, right? Or at least discrimination based on things like gender, caste is bad, and so the goal is to then be biased towards cases where these discriminatory practices that exist in our society, we can remove it, right? That doesn't mean it's fair. That just means that everybody is treated equally, in which that what that might mean is these people who have historically benefited might get their benefits removed a little bit. The other way to think about it is in the case of United States, again, right, or United States versus Nepal, this is more developed and the Nepal is not. And the goal is not to turn Nepal into United States. The goal is to turn Nepal into its own version of happy, productive society, right, where everybody has jobs, whatever people desire. And so what we want is biases towards those outcomes. The way people talk about this is like bias towards human rights, bias towards democracy, bias towards like shared cooperative behavior, which is again a bias. It doesn't exist in our society, so we need to nudge the algorithm towards those outcomes, which in some sense, as you said, right, is introducing biases. But introducing biases intentionally and with an explicit goal in mind. in terms of behavior. I think we have time for one last question, maybe.
Sure, just maybe we can do one last question from Vivek Ji. Vivek Ji.
Hi, Shreyasha Ji. Thank you for the presentation. My question was we see how the AI is now being used for surveillance in different countries, and also it's targeted for a certain group of people. And we have seen the outcomes, how it can turn to a lot of hate crimes, a lot of stuff like that. So what do you think about that, in terms of policing the AI itself, in regard of what will happen in the future? So what's your take on that?
So in this case, I am slightly pessimistic in the sense that there's both, right? Like a lot of desire for these algorithms being policing, it makes people feel safer. And there's also a lot of like other incentives, money, power for people who get to deploy these systems. So I think there will be more and more of these systems in the world, which makes me like slightly sad. Personally, I think they're a terrible idea. Partly because, right, the idea of like community safety does not just come from policing. Rehabilitation should be a big goal of making people safe, and you cannot really rehabilitate by predicting. The other thing is like using AI can only predict crime, and so you can then respond to it. It does not prevent crime. And what you want is to prevent crime, and that only happens when people have their basic needs met. When like a lot of people get to bad activities because they're desperate, or because the society teaches them that it is okay, and you cannot really solve societal problems with just technical solutions, right? So in a two-part, I think this will go on, hopefully not like in a way that it cannot be dismantled, but at the same time, I don't think it should. And as technologists, if we are at a place to implement these systems, we should just refuse.
Thank you.
Thank you, Shreyasha Ji. I think it was a lovely interaction. We had great questions coming in. I think we're almost at the end of our webinar, and on behalf of GIIS, I would like to thank Shreyasha Ji for her time, and also for the participants joining our webinar. It was a really great interactive session. Thank you, Shreyasha Ji, for your time, and we really hope to collaborate with you in the future as well. I think it was a great presentation, and we all had a great learning and takeaways from it as well. Thank you for sharing your experiences.
Thank you. And thank you for the audience to be like so interactive. You guys asked great questions. I'm glad you listened. And to end, this is the new version of the word cloud. We have some new words here. So at least I think I made some difference. So thank you so much. And likewise, I would love to collaborate in the future as well.
Thank you.
Thanks.